Java inheritance. So here we are going to learn what is and why inheritance is and for, and we'll talk about the object class, which is the root class of every single Java class, and then we are going to see how we can create or derive a child class or subclass from a parent class. We'll learn constructor calling chain. We will learn how we can use what is called the super keyword, and then we'll talk about the concept of overriding methods. Okay, overriding methods in a parent class by the child class, and then we'll talk about type casting or type reference, and then we'll talk about the final class and final method at the end. So what is inheritance? So inheritance is a concept in which a child class automatically inherits the properties and methods defined in a parent class. So a parent class sometimes called a superclass, and child class is called sometimes subclass. Okay, so I'm going to use these terms interchangeably. So superclass is a parent class, subclass is a child class. Okay, so inheritance is basically child class inherit all the properties and all the methods defined in a parent class. So it's one of the primary feature of object-oriented programming, along with encapsulation and polymorphism. So why you want to use inheritance? Mainly for reusability, because once you define a set of properties in a parent class, any child class can inherit those properties. Same thing for the methods as well. So once a set of methods are defined in a parent class, then those methods can be used by the child class automatically. So the child class or subclass needs to implement only the differences from the parent class. So those differences could be extra properties and extra methods. So let's see examples. Oh, before we move on, so let's talk about the object class. So object class is a mother of all classes in Java. Okay, so all classes are in fact subclassed or extended from the object superclass. So in fact, object class is the only class that does not have a parent class in Java. So object class has a set of properties and methods that are going to be inherited by all child class of object superclass. Those include, for example, getClass method or equals method or toString method. So if you actually go to API of the object class, you are going to see a set of, so you can see it doesn't have any parent. Okay, so these are the methods that could be inherited by all child class: clone, equals, finalize, getClass, and notify all, toString, wait, and things like that. Okay, and so the every Java class will have these methods available. Okay, so if you see class hierarchy in this particular example, let's say we have a class A and class D that are direct child class of object class, and then we have class B and class C, which are child class of class A. So in this case, class B and class C will inherit all the properties and methods of object class as well as class A. Okay, so in that sense, every class in Java will inherit properties and methods of object class. Okay, so let's see how we can derive a subclass, meaning how we can create a subclass from a parent class. So we use another term called the derive, meaning create a subclass or child class from a parent class. So child class extends parent class by using the term extends keyword. So let's assume we have a parent class called a person, and then we want to create or derive a child class called, let's say, student. So the way that a child class is created from a parent class is in the child class declaration you are going to use extends. So here student extends person. Okay, that means student is a child class of person parent class. Okay, which means student class will inherit all the properties and methods defined in person class, and also any parent class of person class, for example object class. Okay, now accessibility of a parent from child class. So a subclass inherits all the public and protected members of a parent no matter what package the subclass in. So when I say all properties and all methods, it's not completely true. It is actually constrained through the accessibility we learned yesterday. Okay, so if the subclass is in the same package as its parent, it also inherits the default members of the parent. Okay, so this is something that we learned yesterday, right? If you remember, we have 4 access modifiers, right? Public and protected and default and private. Okay, so when I'm saying all methods and all properties of a parent, I'm assuming these constraints are kind of understood. So what you can do in a subclass regarding fields or properties, so the inherited fields can be used directly just like any other field defined in a subclass. Okay, so in a subclass they can actually access the parent class's property just like if it is its own field. In the subclass you can declare new fields, okay, so that are not in the parent class. So that's the extra fields that you can define in the subclass. Subclass does not inherit private members of the parent class, however. This is accessibility that I mentioned in previous slide as well. And so private members cannot be accessed by the subclass. Okay. However, if the subclass has a public or protected methods in which those private fields of the parent class are actually used, that's perfectly fine. I mean, those methods should be accessible by the subclass. What you can do in subclass regarding methods. So the inherited methods of the parent class can be used directly as if it is its own method. And of course you can write new instance method in the subclass. Okay, so this is actually the concept of overloading, which is a very important concept. In a child class you can override existing method in a parent class, okay, by providing same method signature, and it is called overriding a method. Okay, and it will actually provide some polymorphic behavior, which we are going to talk about later in detail. Okay, so we'll see an example of this overriding method in a few seconds. So you can declare new methods in the subclass tree that are not in the superclass, of course. So basically, in a subclass regarding methods, you can do 2 things. You can add a new method that is not present in the parent class, or you can override existing methods of a parent class. providing a different behavior or different implementation. Alright, so let's do exercise 1. So here we are going to actually exercise all the concepts that we have learned. Okay, so I'm going to actually use this example to explain the concepts we talked about one more time. Okay, so let's go to the end-zone lab documentation. So we are going to build brand new application, but the application is also provided. So in this case, what we are going to do is we are going to create 3 classes. The first is person class, which is the parent class, and then we are going to create student class, which is a child class, direct child class of person class, and we will also create another child class of a person class, which is teacher. So teacher and student, those are direct child classes from person class. And then we are going to create international student class, which is a direct child class of student class. Okay, and then we are going to call methods of person class and student class and international student class, and we can access method as well. Okay, so let's assume we have created a project, and let's take a look at the person class. Okay, so person class has 2 properties, name and address, and then it has a getter and setter methods of these 2 properties. Okay, so get name, set name, get address, and set address. Then we create student class, which is a subclass or child class of person class. Okay, so that looks like this. So student extends person class. So students will add its own properties, school and grade. Okay, and it does add its own set of methods. So basically those new methods are getter and setter methods of these 2 new properties. And then we create international student class, which is a direct subclass of student class. Okay, so here we define international student class extends student class, and international student class has an extra property called country. Okay, and it does have its getter and setter method for that country property. And then teacher class. Teacher class is a direct child class of person class. Okay, so here the teacher class has subject property, the extending parent class. And then we write some code here. So we are going to create a person instance. Okay, and then we are setting the name of the person. So the first person instance has a name of Tom Jones. And then we create a student instance. Now student instance can access the set name method from its parent class. So this set name method is from person class, right? So you can see the set name method of person class can be used in student object as if this method is in student class itself. Okay, and then student will call set school method, which is only present in student class. And then we have international student. International student can access any method in its parent, the ancestor, chain. So it can call the set name method of person class. It can call set school method of its direct parent class, which is student class, and then it can call its own method. Okay, and same thing for the teacher. Okay, and then we display the values of those. It's pretty straightforward, right? Okay, so I'm gonna move on to the next one. 1.3. Here we like to display class instance hierarchy through the get superclass method of class. So as I said before yesterday, that is in fact the class. Okay, so class represent class. So every class that is loaded in JVM is represented by class object. So that class object it has the get superclass method. So here basically we want to actually display the class chain. Okay, so let's actually run this application, then I'm going to explain this code. So this is what is the name of this application? Okay. So I'm going to open the project and we go to Java SC inheritance. Excuse me. Okay, so the name of the project is my people example. Okay, so this one I'm going to run it. Okay, so you can see we are seeing the hierarchy of international student class. So you can see international student class is a child class of student class, and student class is a child class of person class, and person class is a child class of object class. Okay, so that's basically what this code does. Okay, so let's take a look at the code from the lab documentation, because it looks easier to read. Okay, so this is the code. So from international student one object we can call a get class method. So here this class object should actually represent international student class. Okay, and so we can so now we want to display hierarchy. So basically we like to find out the superclass of this international student class. So this class 1 represents international student class, right? So we get the superclass. Okay, so until superclass is not null, so this is going to be stopped when we actually reach the object class, because object class does not have superclass. Okay, so object class will actually return null. Okay, so that's when we actually stop. So here we are going to get the name of this child class. So and then we're going to get the superclass. Okay, that's the parent, and so we display the child class and parent class, and then we are going to replace the class 1. Okay, with the parent class, and then we just do it the same thing. So that's how we actually get the data of this. Okay. Alright, so I'm going to give you guys about 15 minutes to do this exercise, and if you can, add another child class to this international student class. Maybe we can call my international student as a child class of the international student class, and then see whether you can display the class hierarchy like this as well. Okay? Alright, so let me stop the... So next topic is constructor calling chain. We touched upon this a little bit before. Okay, so constructor method of a superclass or parent class gets called automatically when a child class object gets created. Okay, so the before, well, let me actually talk about the constructor method first. So we talked about several times that when an object gets created from a class, right, the constructor method of that class is invoked, okay, to mainly initialize some of the fields maybe of that object. Okay, now before the constructor method of that class gets called, it will check whether that class has a parent class or not. If the class has a parent class, then parent class's constructor gets called first. And if that parent class has another parent class, then that parent class of the parent class will be, the constructor method of its own parent will be called first. Okay. So for example, let's say you are creating a student object from student class. Okay. So before constructor method of student class gets invoked, it will call the constructor method of person class, because student is a child class of person class. And of course, before constructor method of person class gets invoked, it will call the constructor method of object class. Okay, so these are done. These automatic constructor call chaining is done automatically for you, so you don't have to do anything. So let's see an example. So we have defined the person class. So this is a child class. By the way, the reason the person class does not say extends object is because that's assumed. Okay, but you can say person extends object. That's perfectly fine syntax. Okay, but because object is always a parent class, it's not necessary. Okay, so we define a person parent class. Okay, so person parent class has a constructor. It's just constructor will display person constructor is called. Then we define student class, which extends person class. Okay, so student has its own constructor method, which is displaying student constructor is called. Now in the main class, you created a student object. So when student object gets created, the student constructor is going to be called, and before student constructor gets called, it will call the parent version of constructor method. So when this object gets created, what we are going to see is person's constructor method is called before student constructor method. Okay, so if you see what's happening from the picture, this is what's happening. So when the student object gets created, it will try to call the constructor method of the student, and before the constructor method of student gets called, it will check whether student is a child class of a person, and then if the student has a parent class, if student has a parent class, in this case person class, that parent class's constructor gets called first. So if you see the number, it goes over here first, and then it finds that student has a person class parent, so it goes to the parent class's constructor, and then once the constructor method of the person class gets invoked, then it will comes down to student class's constructor, and that gets executed, and then it returns. Okay, let's talk about the super method and super property name. Now, a subclass can explicitly call a constructor of its immediate superclass by calling super constructor call. Okay, so instead of depending on that automatic or implicit constructor call chaining, a child class can explicitly call the constructor of a parent class. Okay, so the super constructor call in the constructor of a child class or subclass will result in the execution of relevant constructor from the superclass based on arguments passed. Okay, so the reason you might want to call super method instead of depending on that implicit automatic constructor call chaining is when you want to invoke a constructor method with arguments. Okay, so let's see an example of this. So in this example, we have person class, and person class has two constructor methods. One is the no-arg constructor, the first one. Second constructor takes name argument. Okay. Now in a student class has two constructors. Again, no-arg constructor, the first one, and then student has another constructor method which takes three arguments. So now when it receives string and school and grade, it could actually set like a this dot name equal name. That's perfectly fine. Or it can actually depend on the constructor method of the superclass. So in this case, it's going to call super a name. So what it means is that I'm going to call constructor method of my parent, immediate parent, passing one single argument. And because there is a constructor method in person class that takes this single argument, this will, this logic will be executed. Okay. Now, if there is no constructor method that takes this string argument, then that's a compile error. Okay. All right. Some of the constraints of using super method. Okay. The super method must occur as the first statement in a constructor in a child, the class's constructor. Okay. So here, if you call super method after this school statement, that's a compile error. So this super has to be always the first statement in a constructor of a child class. You cannot use the super method in ordinary method. It has to be used in a constructor method of a child class, and it has to be the first one. Okay, so I mean, this is going to be detected by the compiler if you make a mistake. So it's not a big deal. Okay, super.property name. So you can also access the parent property by using super.something. Okay, so here, assuming student is the child class of a person, so inside the constructor, you can actually access the super classes name and address fields by having super dot. Okay, yeah, this is actually rarely used. All right, so let's do exercise 2. So let's take a look at the exercise 2 lab document. So here we are going to exercise super method and super reference. Okay, so here we are going to have another constructor called the so this is the person has a person constructor. Okay, and student has a student constructor. So this is exactly the same code that I have used in the slide presentation, so nothing much to explain. And student, international student, has his own the constructor. Okay, and the teacher has his own constructor. So when we created international student and when we created teacher student, what we are going to see is, international student object, when it gets created, it should actually call the constructor method of the person, constructor method of the student, and constructor method of international student. And same thing for the teacher. Okay. Alright, so that's 2.1. And 2.2, we are going to exercise super method. So I should actually say super dot because super is rarely used without the arguments. The reason you want to use super method is when you want to invoke parent class's constructor method with argument. Okay, so this is again same example that I have used in the slide. Okay, right, so nothing much to explain. It's just to have international student. Okay, and here we are basically creating international student passing 4 arguments. Okay, and in international student, we are basically calling the parent constructor method. So parent should have name, school, and grade. I mean, parent should have this. Okay. So if the parent doesn't have this, then again that's a compile error. All right. So at super reference again, you can actually so this is protected access modifier. Okay. So what it means is that the subclass child class can access this too. Okay, so instead of making private, we actually change to protected. Okay, all right, so that we can access it. Okay, if you don't change this one to protected, then the super dot something will not work. Okay, because child class cannot access private member. So you might want to actually leave as a private and see whether you can actually access it from the child class. Okay, and you should actually experience compile error. Okay, so this here we actually change the protected to exercise. Okay, so you can access it like this. Okay, all right. Okay, so I'm going to give you 10 minutes to exercise this, and let's have 10 minutes break instead of 15 minutes break. We'll have a 10 minutes break. So we'll be back at 45 after the hour. Let's move on to the next topic. Overriding methods. We already talked about the difference between overriding methods and overloading. So let's talk about overriding methods in a bit more detail. In fact, this is pretty important concept. A child class overriding methods of a parent class. So if a child class needs to have a different implementation of a method, well, in this case, we are talking about instance method of a parent class. Child class can override that instance method. Okay, so this is called overriding method. Okay, now this overriding method has to have the same method signature. By the way, when I say method signature, I'm talking about same method name, same set of parameters. By the way, same set of parameters. I'm talking about the types as well as number of parameters. They all should be the same. Okay? If any of those are different, then that method will be considered as a different method. Okay? So when you want to override existing parent method, then the method signature has to match. Okay? Now, in terms of return type, the overriding method can have a subtype of a parent method's return types. It doesn't have to be exactly same type, but it could be a subtype. Okay. All right. So let's see an example. So suppose we have a person parent class, and this person parent class has a getName method. Okay. And what we want to do is, we want to have a different behavior. So, when the getName, we want to provide a different implementation. So, in a child class, in this case, student class, we want to override that getName method. So here, we want to provide different name. Okay, student getName. All right. So in this case, the method signature has to be exactly the same. So you can see getName, the method name is the same. In this case, we don't have any parameters. But if there happen to be parameters, those parameters have to be exactly matched. Number of parameters as well as the data types of those parameters as well as the order of those parameters have to exactly match. In terms of return type, this child class's overriding methods return type could be a subtype. So it could be like, so string is not something that you can actually extend. So in this case, both of them should be actually the same type, like a string. Okay. All right. Now, when we call the method getName method on a student object, it will call the child version of the getName. So it will return student getName instead of parent version of the getName. Okay. So that is overriding methods. Okay, so the access modifier of overriding method can also be more but not less access than overridden method. Okay, so for example, protected instance method of a superclass can be public but not private in a subclass. Okay, that makes sense, right? If you don't want to actually make it less in a child class. Okay, that doesn't make any sense. Okay, so in general, you want to actually use the same modifier, access modifier, with a parent class. But if you want to actually, use a different modifier, has to be the less constrained access modifier. Okay, so this is exercise 3. So let's take a look at the exercise 3 lab documentation. Okay, here we have, we actually removed the this system out statement. Mainly, we want to see more clean output. That's all. You can leave this too if you want to. Okay. Now we are going to add a method called myMethod in a parent class, and this will be overwritten by subclass. Okay. So now in a student class, we are going to override that myMethod, and the method signature has to match. So it has to be the same name, and the type of parameters, the number of parameters and type of parameters should be exactly the same. So here we have only a single parameter. And now in terms of return type, both of them are void, and in terms of access modifier, both of them are actually public. So they all meet the requirement of overriding method. And the same thing for international student. International student will actually override myMethod, with the same method signature. And then we are going to call these methods. So we are going to call from person object, student object, and international student object. And each of those myMethod will actually return the correct method. It will actually invoke the correct version of the method. Correct version of the object instance. So in this case, it should actually invoke myMethod version of international student class. This one should invoke myMethod of student class, and this one obviously should invoke myMethod of person class. So that's pretty much it. Now I am going to I'm going to skip 3.2 because we are going to actually do the same exercise when we cover polymorphism. So don't worry about the 3.2 for now. Let's see. Well, because this is actually a bit simpler example. You can just run the application and see what happens. But I'm not going to actually spend time explaining this because we are going to actually spend quite a bit of time explaining polymorphism. You're welcome to try this exercise. Just run it, what happens, and maybe you have some questions, and that should be good. So that you can ask those questions when we talk about polymorphism. So I'm going to give you just 5 minutes to do this exercise. Boarding. And we are going to start the next topic, which is type casting. So what is type? So you probably have heard the term type. In fact, this is very important concept. When an object instance is created from a class, we say the object instance is a type of that class and is superclass. So for example, let's say we have created a student object instance like this. Then we say like this: student1 object instance is a type of student, or it is a student type. So these are the explanation of what object is, whether an object is a particular class, what type is. So you can think of a type, when we say class, you can think of it as a type in Java. So in fact, you can interchangeably use the term type and class in Java. So I say student1 object instance is student type or student class. Now, student class is also a child class of person, right? So you can also say student1 object is also person type or person class. That's perfectly fine. Because person class is a child class of object class or object type. You can also say student1 object is a type of object, or student1 object is object class. So these are all perfectly fine description of what type a particular object is. So you probably noticed that I'm using type and class interchangeably. Alright, so what is a big deal? So an object instance of a particular type or a particular class can be used in any place where instance of that type and its supertype is used or called for. Okay, so let's talk about an example. Okay, let's say student1 object instance is a type of Java student. Okay, so it's actually object instance from Java student class, and Java student is a child class of student, and student is a child class of person. So you can say student1 object instance is a type of Java student, and person type or person class. Okay, now student1 object can be used in any place where object instance of type Java student and person is called for. Okay, so you might still ask, what are you talking about, right? So if you don't understand what I'm talking about on this slide, just wait a minute. We'll actually explain it again. I'll explain again using example. By the way, this enables polymorphism. Okay, and again, we'll talk about polymorphism in detail in another presentation. So I'm gonna actually hold on explaining what polymorphism is in this context. Okay, basically, this is what I'm talking about. This is an example. So object instance of a subclass is assigned to a variable of a parent class through implicit type casting, and this is safe because object instance of a subclass is also type of superclass. Okay, so let me actually explain again using an example. Let's assume we have student class, which is a child class of person class, and we have a Java student class as a child class of student class. So here we created Java student object. Okay, so this is what we have seen so far. Basically we say the type of Java student object is Java student because we just created. Okay, now what you can do is you can also say this Java student object is a type of student, like this, or Java student is also a type of person, and also Java student is a type of object. Okay, these are all perfectly fine syntax. So this is called the implicit casting because Java student is always a type of student, Java student is always a type of person, and Java student object is always a type of object. Okay, so let me actually explain this statement one more time. So an object instance of a subclass, for example, like a Java student is a subclass of the student and person, right, can be assigned to a variable of a parent class. So these are the variables of parent classes, right? Student variable and person variable and object variable. So your object instance of child class can be assigned to parent class's type. Okay, so this is what I'm talking about in previous slide. An object instance of a particular type can be used in any place where instance of that type and its supertype is called for. So that's basically what I'm talking about here. An object instance can be assigned to a type of a variable of its own type or its parent type. Okay? Alright. I'm gonna actually let me see. So let me actually explain this slide. So in this case, we have object instance whose type is of Java student, right? So basically what we have done is that we created Java student object instance. Okay, so this is the Java object instance in memory. Okay, however, we could have a variables, okay, whose type is its own type and its parent type. Okay, so this person variable actually points to this object even though it's a type of person. The student variable, even though the variable itself, the type of it is a student, is actually pointing to Java student object instance. And of course, this is a Java student type is actually pointing to this. Okay, so the implication that the variables of this is pointing to actually the Java student object instance. I mean, this is actually has an implication later on when we talk about the polymorphism. But I just want you to understand, this particular code, okay, is represented by this picture. Okay. Alright, so that's implicit typecasting. So, we have learned the typecasting yesterday a bit, right? So we talk about the primitive typecasting, and we also talk about object typecasting, right? So we talk about implicit casting and the explicit casting. So we're actually going over one more time, but we're actually looking into this typecasting from, let's say, type perspective, okay? Alright, so explicit typecasting is that an object instance of a superclass must be assigned to a variable of a child class through explicit typecasting. Okay, so what it means is that when you are creating a student object and then assign to person, this is safe because every student is a person type. There is no deviation. Okay, so every student is a person type. However, if you want to do the reverse, meaning if you want to assign a person object to student, then you have to cast it, because not every person object, so person class could have in fact have a teacher object, right? So not every person object is a student object, student type. So when you are actually going from a bigger, meaning parent, to a child, you have to cast it. So this is an indication that you are saying to Java compiler that you know what you're doing. Meaning you are sure that this person type object, even though it's a person type, is actually pointing to student object. Okay, so basically meaning you are sure that is the case, that's the reason you can actually cast it. Okay, so when you are actually going from parent type to a child type like this, you have to do explicit typecasting. So we talked about a little bit yesterday, but I haven't really explained why you have to do it, right? Now I'm telling you. The reason you have to do explicit casting in this case is because not every person object is a student type. It could be teacher type. Okay, so Java compiler wants to make sure that you know what you're doing, meaning you are you have assurance. You're giving an assurance to a Java compiler that this person one object type, the variable, even though it's a person type, it is in fact pointing student object. Okay. Alright, so not doing it will result in compile error, and compiler wants to make sure you know what you're doing. Okay. Alright, so this is an example. So this is explicit typecasting. So when you go from parent class to the child class, from here to here, you have to do explicit typecasting. Alright, now even if you've done explicit typecasting so that you don't have any compile error, you could end up having runtime type mismatch problem. Okay, so let's see an example. Let's see we have student object and we assign to person variable type. Then we created teacher, which is a child class person, and then we assign to person 2 variable. So this is perfectly fine. Okay. Now, when we assign a person type object to student 1, this is okay. There is no runtime error because even though person 1 is a person type, is actually pointing to student object. Remember this picture? Okay. So it's actually pointing to student object, so that's perfectly fine. However, if you try to cast this person 2, which is a teacher object, is pointing to teacher object instead of student object. Now if you cast it like this, there is not going to be any compile error, okay, but it will result in runtime error, and this is bad. Okay, when you experience runtime error, that's pretty bad. What it means is that your production system could actually have this kind of problem. Okay, your application has been running for 2 months perfectly fine, then all of a sudden it crashed because of this kind of runtime error. Okay, so this is pretty bad. So that's the reason. In fact, later on, I'm going to talk about the genetics in a few minutes. Okay, so yeah, so this just remember the you could have a runtime type mismatch exception, meaning this problem could happen during runtime. Okay, instead of compile time. Okay, so having this kind of problem on runtime is actually really bad, as I said before. So best practice guideline says you want to make sure that object instance is in fact really a student. okay, before you are actually writing this kind of code, running this kind of code. And that's the reason you want to use instanceof. So this is something that we learned yesterday, right? You can check whether a particular object instance is in fact a type of something, okay? So in this case, before you are assigning to this, you want to make sure that person2 is instance of student. If it is not, this is not going to be executed, meaning there will not be any runtime error. Okay? So you check this one first. Alright, now from Java SE5 actually provides better solution. It's actually providing what is called the generics. Okay, so generics is designed to detect type mismatch problem at the compile time rather than runtime. So don't worry about it for this right now. We'll talk about this generics on day 5. Okay. Alright, so just for now focus on this up to this point. Okay, so let's do exercise 4. So we're gonna do implicit typecasting, and then we are going to explicit typecasting. So we're gonna actually do explicit typecasting. The runtime type cast exception will actually experience this runtime type cast exception. And the third, we are going to use instance of, so that we don't actually avoid having runtime type cast exception. Okay, so take a look at this code. Okay, so again, this is pretty much the same code that I explained in the slide. Okay, so you can actually assign student object into person2. So here we are actually assigning to person2, okay, and we can assign the previous object instance is person2. Okay, so basically you can assign object instance of a child class to a type of a parent. That's basically what you're talking about. Okay, same thing for international student, and so international student can be assigned to the person or to a student type. Okay. Alright, so that should work fine. Now for that too, here we are going to experience runtime error. Okay, so so we're gonna actually run. Let's actually run the my type mismatch example project 1. Yeah, so let's run this one. Okay, so you can see there is no compile error. So if you take a look at this, if you take a look at the source code, okay, there is no compile error. Okay, but when you run it, you actually have this type casting exception. This is the type mismatch we are talking about. Okay, it does tell you, in fact, okay, it does tell you teacher cannot be cast to the student. Okay, because teacher is not a student type. Okay, so if you take a look at the code, okay, what we have done is we were assigning. So person2, so here basically we have a person1 and person2 variable who's pointing to student object and teacher object. Now we are performing explicit casting to, so this one is perfectly fine because the person1 is pointing to student object, but here, as we have seen in the slide, when you are assigning to person2 object pointing to student object to person2 is actually pointing to teacher object, and then you are casting to student type, that is type mismatch problem. Okay, so the third exercise is we are going to check whether person2 is instance of student or not. Okay, and we avoid runtime errors. Okay, alright, so I'm gonna give you 10 minutes to exercise this. Alright, so next topic is final class and final method. So what is a final class? It's a class that cannot be extended. Okay, so if you do want to make a class that you do not want that class to be extended, meaning you don't want any child class from that particular class, then you can make that class as a final. So the way that you can make a class to be final class is using final keyword. Okay, so you say public final and class name. Okay, yeah, actually I think I have actually public class is missing here. Okay, examples of the final classes from JDK include a string class. So you cannot create a child class from string class. If you try to do that, that's a compile error. Same thing for integer class. Okay, so you cannot create the final class from the integer class. So all wrapper classes, integer class, long class, double class, those are all final classes. Final method is a method that cannot be overwritten, meaning this is a method that cannot be overwritten by a child class. Okay, so if you want to make a method as a final method, then you say a final keyword on a method. Okay, static methods are automatically final because those are the methods that cannot be extended. I mean the overridden in the child class. Okay, so let's do exercise 5. So here basically we are going to, you can just open the project. So we make a person class as final. Okay. Yeah, so I should say person final class here. And then you try to extend this person class. Okay. Then you are going to experience compile error. Okay. So you can see, the compiler says cannot inherit from final person class, because person class is declared as final class. Okay. The 5.2 is again, if you try to extend string class or wrapper class, again you are going to experience compile error. Okay, so again, if you try to extend string class, compile error. Same thing for integer. Okay, so when you see Java documentation, you can find the string class is declared with final keyword. Okay. The 5.3 is for experimenting with a final method, meaning a method. Okay, so let's say we define a person class. It's not a final class, as you can see. It's just a regular class, but it contains a method, and it makes its method as final. Okay, so this method cannot be overwritten by child class. Okay, so if you if the teacher class, now if you try to override that final method, then you're going to experience the compile error. Okay, now the question is, why you want to use final class and why you want to use final method, right? Okay, so that's something I should actually include in the presentation. So if there is a class that you do not want any other behavior on that class, okay, you want to make it as a final. Same thing for final method. If you have a class and if you happen to have a method or set of methods, you do not want any deviation from that particular method, then you want to make it final. Okay, so it's actually application design. It's completely up to you, but those are the guidelines that you want to use, whether you want to make a particular class or a particular method of a regular class to be final. Okay, and exercise, so this one we are going to skip it because we are going to actually use the same example in our polymorphism class, the presentation. Okay, so I'm gonna give you just 5 minutes. It's mainly just to verify. You cannot actually extend final class, or you cannot override final method. Okay, so I'm gonna give you just 5 minutes to do exercise 5.